This video is all about resistance. We've seen previously that a cell provides the potential difference to allow the current to flow and transfer energy from the cell to the bulb. However, when current flows or when electrons try to move, there is resistance. Just like when you're running through the air, there's air resistance or drag. There's always something that tries to slow you down. And in electricity, we just call it resistance. With this example though, it's the component that causes the resistance. So the more components that there are, the bigger the resistance is likely to be. So the current, or I, through a component depends on both the resistance, R, of the component and the potential difference across the component. So the greater that the resistance is of the component, the smaller the current for a given potential difference will be. So if potential difference doesn't change, but the resistance goes up, that means the current will reduce. You'll see later something to do with Ohm's law, but for now the equation is potential difference equals current times resistance. Potential difference is measured in volts, or capital V. Current is measured in amperes, or amps, capital A. And resistance is measured in ohms, or the Greek symbol omega. So one skill you'll need is to rearrange the equation. So if you like triangles, it looks like this, where the potential difference goes at the top, and then current and resistance are multiplied and go next to each other at the bottom. Or you can remember it as V equals IR, V equals I times R, or PD equals current times resistance, just maybe in the shortened form. Linked to this topic, but we won't go into it now, to make you aware is required practical 3, so take a look at other YouTube videos to see what that's all about. But in essence, resistance of a wire, important is at a constant temperature. The longer the wire, the higher the resistance. And also resistors in series and parallel. Resistors in series add up, and in parallel, the resistance is always less than the combination of the two. Before moving on, it's worth mentioning about different types of resistors. So fixed resistors, the value of the resistance remains constant. The circuit symbol is more like a rectangle, but in other components, resistance can change as the current changes. So an example of that would be the bulb. As the current goes up, it gets hotter, and that means the resistance goes up, but more on that later.